I think Philippe has a viral fever, so he's not here. So I'm filling in. I'm Prabhu. You guys may not know me. Show of hands if you guys recognize any of these projects. Atom, Blend, Chen, Usai. Okay, I'm not surprised because I've been working on these projects for like 3 years now. Hardly told anybody. So first time I'm going to present my work, show what it can do, and I have sponsors. So if you are a EU taxpayer, thank you so much. Your tax money is funding my open source work. If you're not a taxpayer, don't worry, I take private sponsorship also. So my colleague Philippe came up with this title, "Open Source is a Virus." Right? It's a big question to answer in 30 minutes. So I thought maybe I'll simplify it. I'll just take a project and then discuss whether this given project is a virus, as a malware, and is the text visible? Let me see if I can zoom in a bit more. Okay, so do people here know FFmpeg? So yeah, it's the number one free-loaded open source project in the world, right? Like everybody just wraps it. Hardly anybody sponsors it. While working on this slide, I just did a find of FFmpeg on my Mac, and pretty much Slack, Canva, all of these apps have FFmpeg, right? Do you guys remember the 3CX supply chain attack, 2023, where FFmpeg DLL file was hijacked, and then it was in the news, and everybody was blaming FFmpeg people, even though FFmpeg developers actually do not publish any binaries at all. So FFmpeg is actually a source-only project. So if you want to use FFmpeg, you have to download the source and compile it yourself, right? But then, nobody has time for it. So what we do, we go to a registry, right? And then we search FFmpeg, and then we just pick something. So this is on NuGet, NPM, PyPy, Maven, right? None of these are official packages, right? So we actually don't know what's in any of these open source components that we're going to use. And it turns out when I, for example, did a diff of the FFmpeg used by Canva and Slack, they were actually differing. So one has to assume that these two companies, different companies, took a version at some point in time, somehow built it. So there is a binary file on my Mac, and we can't ask Canva or Slack, hey, tell me the version of FFmpeg you actually bundle, right? They're not even going to acknowledge. So it's entirely on us to determine whether we have a virus or a malware, whether my laptop here connected has a virus or malware, right? Let's also try to play a game. So I think a lot of people said they know FFmpeg. Can we try to guess the capabilities? What can FFmpeg do? Can it work with audio and video devices? Yes. What about network? Okay. GPU? Okay. Does FFmpeg do any crypto mining operation? Okay. What about AI? Does FFmpeg have any AI capabilities at all? Right? Yeah, we can of course ask an LLM tool, and it's going to just guess like us, right? How do we know any of these things? So what happens in the field when it comes to identifying malware across ecosystems at scale, right? There are a lot of techniques. I think we saw talks about virus total and so on. So for the first approach is running a tool like strace. So this is done by OpenSSF people, funded by Google, Microsoft, and all the Linux Foundation. So they set up virtual machines and computes and download all the open source packages from various ecosystems, install the packages, and then run strace, and then they have rules to see what the packages do, and so on, right? And this simple command actually works. The reason is that many of these malware authors who publish malware on NPM and PyPy are actually very lazy. Okay, so they don't even make an attempt to hide the malware or do anything. Like, I think yesterday they showed how the actual obfuscated code was on the right side. Like, you had a horizontal scroll bar, and then you can scroll and see the payload, right? Like, they don't do anything cool, like even a sleep timer, like the delayed attack we saw this morning. So running an strace command post installation, we are able to catch a lot of malware. Okay. The other approach is, yes, we can just run a lot of Yara rules on binary, right? Like, and most of these Yara rules are like looking for specific bytecode and so on. And it's like, we do get some results, but we can compare hashes, like take segments of the binary, create an hash, and then have a signature database. And Google and Microsoft, I read recently, they're starting to use LLMs. But the question is, like, can we actually do better? Like all these are guesswork and, like, not really interesting. So this was the question I had like 3 years ago before I started working on the 4 ABCD open source projects. And to explain the projects, so usually I do like a workshop. It takes a bit of time, but these are some of the minimum terminologies you need. I'll try to keep it high level, but then I'm always available. I can always give a deep dive. So firstly, static analysis and program slicing, like show of hands, like static analysis. Any fans of static analysis, or people who don't like static analysis? Must be a lot of people. So under static analysis, you have terms like AST, CFG, DDG. Software bill of materials. Okay, that's good. And then under software bill of materials, you have like crypto bill of materials, operational bill of materials. This must be easy, right? Compilation versus disassembly versus decompilation. And source and binary. Libraries like tree-sitter, capstone, Nickstone, or Leaf framework. Okay, so these are some of the libraries other than tree-sitter my projects are using. And then, I'll keep it a bit high level at point. And for the demo, obviously, I have to show the low level. And so there is one condition. Recording is allowed. All my projects are free open source, but don't submit a paper or a grant application yet, because it's not complete. It'll more likely get rejected anyway if you try. So don't do it. But all the other things are okay. So the new hypothesis, the new proposal I came up with, and now kindly funded by EU and others, is pre-computing slice for all ecosystems, like all open source dependencies, everything across ecosystems, right? And what is a slice? Slice is just a subset of information, okay? So for example, software bill of materials could be considered a slice because it's describing just the dependencies a project uses, okay? We can come up with other kinds of slices like this. And my 4 projects can create different kinds of slices, okay? Atom is like an intermediate representation tool for our source languages, okay? And Blend is a binary analysis and slicing tool. So suddenly we can have the source representation of a project like FFmpeg and the binary representation of the same thing, okay? And I have a project called Chen, which is like a network, and there is a REPL command I'll be showing. And then I have a project that's optimized for .NET applications, which is called DOSE. So I have ABCD foundation projects. And the goal is to run all these projects in a pipeline for every project, every open source project in NPM, PyPy, and like people like Microsoft, or so those are the guys who will be running it, Sonatype for Maven and so on. And suddenly we will have multiple representation, like multiple lenses to view the same thing, right? And then once we have that data set, we can then query them, find out what is going on. Let me actually show the demo. I've been talking too long. So what I will do is I asked the question about FFmpeg, okay? Can I make it larger? Is it okay? Let's see. Full screen. Of course. So the demo got. Okay, full screen. Yes. Okay, so what I'm going to show now is basically a way to identify the capabilities of a project. Okay, using my tool called Chennai. It stands for Chen, not AI. But when I use the tool, it will look like AI and kind of thing. So I'm explicitly saying it's a not AI tool. So I think many of us here are used to pen testing, right? Like, so let's say we are given a project and the goal is to pen test and find issues, vulnerabilities, or simply to learn more about the given project or application and so on, right? So we will do manual source code review, right? So we will go through the project, we'll identify the sources, things, get a sense of what it does, or we can, if we have a linting tool or a SAS tool, we can run the tools, we can find look at the results, analyze the results, and so on. Chen is like a tool that will allow you to digest and summarize and figure out what's going on. So what I did here is create a representation for the FFmpeg project, which I'm loading. And while it loads, if I show you the repo, it's github.com/Prabhu and hacklu. So if you go to this repo, it has detailed instructions, and I have added all the sample metadata and everything to basically investigate and so on. And you can follow my demo as well as try it later tonight or back in the hotel. So this is FFmpeg project. So it has 4,000 plus files and 72,000 methods. So obviously it'll take a bit of time to see the source code and like manually review and understand and so on. Whereas with a tool like Chen and Chennai, we can quickly understand it. So for example, I can just say, show me the files you've got, maybe the color scheme. It's okay. Or show me the methods you've got. And with Chennai, it's constantly learning. So as you query and use the project, it will understand what the project is all about, which means you can actually start querying it even if you do not know a lot about the project. So for example, let's say the first goal is to understand whether FFmpeg project needs access to GPU or not. Okay. Why? Because let's say we have a binary and it's trying to access the GPU for crypto mining, and as a EDR tool or as a security expert, we may not know whether it is legitimate behavior or not, right? So we need to know, does FFmpeg really need these capabilities? If yes, which modules or which flows exactly need them? So that's the goal. So what you can do is, there is a syntax, there is a DSL to write these queries. It's all in my notes, and what I do is I actually offer training for companies to author these things. So it says atom.method, I don't know, GPU star. Firstly, let's see if there is any such method. So just .name. So it looks like there are two methods with GPU. And then what I can say is, okay, I have the GPU who are the callers of these methods. Okay, so there are people accessing. So what we can now do is, okay, just tell me the flow. Like I don't care the individual library or the function or something, but just tell me the flow, how it all happens. So we can author data flow queries like this easily with Chen. And what we do is we have a number of these queries which we run in a pipeline in an automated fashion, and that's how we are able to pre-compute the source slice. So this is real data flow. I don't even know the full FFmpeg source code, and either you guys. So what I just said is, look for some init method, look for some GPU method, and tell me exactly how FFmpeg interfaces with GPU, and it plots all the flow, and it even says whether the flow has some mitigations in place or not. So this is like I said, none of these are AI, but these are hardcore static analysis, but it learns about the project as you query, as you use, so makes it very useful. So most people, like when I say static analysis, they immediately think about the static analysis tools of the past, right? And then like, okay, it's all false positives, but Chennai, it's a code hierarchy exploration tool. So it can traverse across layers, even if your layers comprise of source and binaries and so on, it can track the data across, and it'll give you very high quality results. And my notes has a lot of examples like this. So for example, you can just say, instead of GPU, you can say HTTP, and then learn about the flows where a data is being sent via HTTP. So because FFmpeg supports HTTP streaming and so on, it has its own HTTP client functionality, and it's very easy to do. And you can also flip the other way. You can say, show me the flows that starts from HTTP and then goes to my file system and so on. Like I'll let you guys play with these queries. So so this is the first step we do. So we use Atom and then Chen. We have like a set of scripts that is continuously slicing open source packages. So we exactly know the capabilities as per the source, right? So capabilities could be hardware capabilities, software capabilities, dependencies, libraries, devices. And we also compute like rich data flows and everything. So it's not just the strings or symbols anymore. We have a very good idea what the library does. And we do similar thing for .NET. And then the semantic analysis part, I think I quickly covered. And then we have another pipeline where we do the same thing for the binary. Okay, so I have a project called Blint, and what Blint can do is use a library called Nixstone, which is like Capstone. I think Capstone is quite well known, but Nixstone is a new emerging framework that only needs LLVM. So this notes is in my GitHub repo. Okay, and what I want to show quickly is, for example, take one of the method. Okay, so we know that FFmpeg has or uses some graphic devices, some network, and so on. But so this method, av bprint append data. Okay, so we have the assembly text, and then Blint is trying to figure out whether it has any GPU call, any crypto call. So no, this is just like a string append functionality. But what usually happens is when people take a malware and repackage it as FFmpeg, right, on NuGet or npm, they try to copy paste the same function name. Okay, so if you are used to writing Yara rules looking for regexes, right? Which is what most of us do, right? And then like we are looking for this function a b b print data, and we are like, okay, this is a trusted function, okay? But what if this function is actually doing crypto mining in a malicious binary, okay? And more often than not, that exactly is what happens. So, for example, the same function here, right, is performing some malicious operation, and Blint can detect this. And then there is a way to author a Yara rule to basically detect and flag this. I will actually show the Yara rule also. But as you can see, so unless we are an expert in reading assembly, right? Like, so the assembly obviously looks different. So this is the malicious version, okay? And if you look at the safe version, it looks like this. Not all of us are experts in, just reading the assembly text and figuring out what's going on. So Blint tries to create like easy metadata to make it easy to understand what's going on. And this is one of the ways we identify malware based on, for example, we go granular and we look at the individual symbol, individual function, and then we try to match it to the capability that we learned from the source. And then we know that the capabilities in the binary is different or varying from what was originally in the source. So which means there is a supply chain attack or something, some kind of tampering has happened. So we are not dealing with the same binary anymore, and so on. And all these are happening in an automation. So while I'm showing it interactively for a function, a project, we have lots of rules, and in fact, maybe now is a good time to introduce some of the Yara rules that we can author. So, like, the conditions will look like this. So you can say binary type is ELF, but doesn't have NX or canary flag, or as a partial rel row. Blint can identify first stage symbols in case of a loader, so we can do that. Or you can, if you know that the binary is a statically built from binary from Go or .NET or Rust, you can actually dive in and specify specific information, or you can keep it generic. So yeah, all of these examples are in my repo, which I will share. So like I said, we compute high-level representation using source, low-level representation using binary, and then we correlate, so we know what's going on. And then we analyze. We do support Yara, so yeah, wide reach, very easy to get started. But for advanced analysis, I started working on my own REPL tool, which I showed. Okay, and the projects are generic. So the demo I covered the first use case, which is to identify capability discrepancy between source and binary. But my projects are used for multiple other use cases also. So supply chain security, detecting hidden dependencies is obvious. So for example, like I showed FFmpeg, there could be products bundling a vulnerable version of curl, for example, or OpenSSL, right? And we often see such hidden dependencies, and often the vendors themselves may not know that they are actually packaging some of these vulnerable hidden dependencies and so on. So we are kind of helping them understand, and then we are helping them run these tools so they themselves know what they are building, what they are packaging. And I can't tell a lot, but yeah, maybe next year we will show some cool things we found in this area. Then vulnerability verification, yes, that's another thing. So we can verify if you author SAST rules to identify, say, double free or buffer overflows. Yes, you will have false positives. But with our combined analysis, we can actually truly prove that there is a buffer overflow that we are able to see both in source and in binary. And in fact, some of these rules can be authored in just Yara syntax also. I think I might have an example. Let's see. Yes. So, like this. So you can look for certain functions in the semtam symbols, and then you can say, as long as it's not of this function type, and then you can similarly author a Yara rule with the source slice information, and then you can prove that this function or this series of functions have a buffer overflow or double free or and so on. So this is another use case. Malware analysis. Any questions? Anything I should discuss, or maybe we can do questions at the end. So the workflow quickly, like I said, there's like a lot of automation involved, but currently we run Atom and Blint, and then for .NET languages we run different tools, and they have their own pipelines and workflows. And the goal is to basically make not only these open source projects free open source, but also the data set free open source. So I think Philippe, he has a new foundation called About Code Foundation, and my projects are now part of the foundation. So we will be publishing the spec, the tools, and also a data set. So we will spend money on the compute, everything. So we'll pre-compute. So you can download the data sets and you can run the analysis. So you don't even have to create the data anymore. And so this topic was actually inspired by a developer, Armine. So he has a project called Binary Analysis Next Gen, and he had very similar ideas, and I was able to kind of implement it with my ABCD projects. And like I said, the Perl DB will be the database that will host all of these things. It'll be it'll start it'll be a few gigabytes, and then it'll grow to terabytes. So, but there'll be a way to download and so on. So thank you. I will take questions. If not, I'm.
That was quick.
So maybe I didn't understand this correctly, but how does this handle, or does it handle code obfuscation at the binary level?
Okay, I think I had a slide. So those are unsolved problem. For some languages like Rust, we try to demangle. Like Swift, also we try to demangle. But what will happen is in the correlation workflow, because if we have access to the source, we will try to learn how it gets obfuscated. So we will have hashes, for example. So you can say, if this is the source hash, this is the binary hash. So we will have more correlation maps to solve it. And the moment we have a number of these connection points, our tools can then learn and figure out the other bits. Yeah, thank you.
Thank you so much for the presentation. You mentioned several times that Gen AI doesn't learn like AI, but it learns, right?
Yes.
Learns, but it's not AI. By not AI, you mean not LLM? Because some time ago, like 20 years ago, even rule-based systems were actually AI.
Correct.
So what kind of learning is it?
It's just graph. So once you have a network of nodes, you can start adding more properties to the nodes. So the Atom file format has mechanisms in place to dynamically add labels and tags to the connections. So the next time it travels through the path, it will know more about what it is trying to find. So that way, so that's one of the way to cut false positives. So if you have a source and a sink, right, and then you're trying to find the paths, right? Maybe some of the paths are already validated, or some of the paths are not relevant. So with this auto tagging capability, it'll learn and then it'll avoid them, or it'll prefer certain paths which it knows leads to more definite hits. So it'll place those results on the top. And like I ran the queries and you got like instantaneous results, right? If I show you the original data set, it's like 867 meg. So no LLMs can actually scale, whereas Chennai can because of all the optimization. And that's the work I was doing like 3 years.
Thanks for the talk. I guess you have looked at some open source projects. Did you find anything super unexpected until now?
Oh, lots.
Can you give some examples?
No, unfortunately not.
It is a under disclosure. All right, I think that's it. Thank you.
Thank you.